Hello boys and girls, welcome to your first physics lesson. This is Mr. Pancholi. I hope you've all been keeping well. I hope you've had a chance to enjoy the sun, but at the same time get some work done as well. So for your first physics lesson, we're looking at states of matter, and by the end of the lesson you'll be able to name the three states of matter. You'll be able to describe the arrangement and movement of the particles in the solids, liquids and gases states. You'll be able to explain the difference in energy between these different states of matter, and you'll be able to describe and explain the changes of state. States of matter. So a state of matter means what form a material is in at a certain temperature. So for example, if I was talking about water, I'd say water is in the ice form if it's below 0 degrees Celsius. You might put it in your freezer and it turns to ice. That's at below 0 degrees. Between 0 and below 100, it's flowing water, liquid form. Steam is above 100 degrees, for example a kettle. Now that tells us that ice is a solid state of water, flowing water is a liquid state of water, and steam is the gas state of water. The three states of matter are solids, liquids and gases. If you can take a moment there, pause the video if you need to, and just make a note of those three states of matter: solids, liquids and gases. Okay, so continuing, this is what I call the I think state. At the I think part, I want you to have a go at what you think the particles of solids, the particles of liquids, and the particles of gases would look like and how they're arranged. For this, I'd like you to use small circles to represent the particles and have a go at drawing the particles, how they're arranged in each of these three. You might want to copy the boxes down. Pause your video here. Spend about 4 or 5 minutes just thinking about this and drawing them out. And there'll be a part 2 to this just when you unpause it. So pause the video there, have a go at this, and we'll continue once you unpause it. Okay. Now that you've had a go at drawing how you think the particles in these states of matter will look, I'd like you now to write the description of what you think the movement and the arrangement of these particles would be like. So write down how you would describe the arrangement and the movement of the particles in a solid, the same for liquid and the same for gas. Again, pause your video right here and spend about 5 minutes just writing out how you think they are how you describe them. Okay, let's see if you've got that right, and if you haven't, it's not an issue. There's one thing I like to point out is it's never a problem to get things wrong. Don't be afraid to get things wrong. I always like people to have a go, and it shows that if you have a go, at least you're thinking about what could be. At this stage, if you've got it, brilliant. If you haven't got it, this is where you check to see. And I'd like you to, at the end of this slide, pause the video again and just make any corrections to what you wrote down, so you have some notes that are correct. So, in a solid, this is how we'd usually represent them. This is the description part. So, in a solid, particles are what we call a regular pattern. They're arranged in a regular way. You can see they have nice, neat rows and columns. They're all touching. They're all in a fixed position. Because they're so tightly packed together, there's no space for them to move around. So we say that they vibrate on the spot. That's the only type of movement they can do. Solids cannot be compressed. Compressed means squashed together. They can't be squashed together. There's no space for them to get any closer together. They cannot flow. they have the least amount of energy, and they are the most dense. Least amount of energy is because of the fact that they're just vibrating. If you think about someone who's on the dance floor, just slowly swaying side to side, they're not really using much energy. Whereas someone who's really going for it and dancing around and jumping around and being absolutely crazy on the dance floor, they're using a lot of energy. So solids that can only vibrate on the spot have the least amount of energy. We also say they are the most dense. What that means is, for the same size square, solids have the most number of particles inside them. That's what density is about. And we'll spend a bit more time talking about that in the next lesson, in the next video. Liquids. In a liquid, you can see that the particles are still mainly touching, but this time around, they're not in a nice, neat pattern. They're in what we call an irregular arrangement. They are mostly touching, but now they have some space to move over each other. For this reason, liquids can flow. They can, if you think about turning a tap on, the water flows, or if you spill a bottle over, the liquid flows out of it. That's because the particles have got space to move around over each other. They can't be zooming around, they can move over each other. Liquids still can't be compressed. And here's a diagram that shows gas particles. In gas particles, the particles are really far apart. They're not touching. They do not touch at all. However, they do now move around randomly and at random speeds. Some of them are very rapid, some of them can be a bit slow. Because there's so much space in between the particles, the gases can be compressed, which means the particles can be squashed closer together. Gases can flow for the same reason. Gases also have the most energy. If you think back to the analogy I gave about someone on the dance floor, gases are the particles that are dancing around, jumping around, going crazy, so they have the most energy. They are also the least dense, because for the same size square, if you compare the number of particles in a gas, they are far, far fewer than the number of particles in a liquid, which is a little bit more dense, and the particles in a solid, which is even more dense still. So at the end of this, the main things to take away are solids, particles are all touching, and they vibrate on the same spots. Solids have the least energy, most dense. Liquids, irregular arrangement, still touching, but the particles can move over each other. Liquids have got a little bit more energy than solids, but they are also a little bit less dense. And gas particles, they are far apart, not touching. They move randomly at random speeds. Gases can be compressed, flow. They have the most energy and they are the least dense. So why does that actually happen? Well, let's think about how the particles are held together. In a solid, the particles are held together by strong forces of attraction. They can vibrate around the position, like we said. At low temperatures, the vibration is small. But as the solid heats up and we give the solid more energy, the particles vibrate faster. And as they do, they pass that vibration to the neighboring particles. In liquids, the intermolecular forces, that's the forces between the particles, are a bit weaker than in a solid, so particles can move over each other now. Again, they move faster when we heat them. And in gases, there is almost zero intermolecular forces between the particles. The bonds are broken, and there's very, very weak forces that are even causing the particles to attract each other. Gas particles can move around rapidly or slowly. They move at random speeds. And again, as the gas heats up, the particles move faster. So at this stage, I'd like you to pause the video and copy out this table and fill it in the best you can. If you need to and you're absolutely stuck, you can obviously rewind the video and go over the other things that we covered so far to see what needs to go in the boxes. There will be an answer, model answer in the next slide. But at this point, pause it and see how you can do. Okay. I hope you gave yourself enough time. If you haven't, then obviously give yourself a bit more time. But in the meantime, check your answers to this. This is a model answer for the sheet. Again, pause the video and allow yourself some time to fill in your table. If there's anything that you think is wrong, please do correct it. I'd like you to have the correct notes in front of you before we carry on. So pause the video and just compare your answers. Okay, now let's think about this. All materials, they don't always stay in the state of matter they're in. For example, water. If it's in a solid state, it doesn't always stay as ice. If we take it out of the freezer, it turns back to liquid water. Same thing with liquid water. It doesn't always stay as liquid water. If we leave it out in the sun, it might begin to evaporate away. If we put it in a kettle, it might begin to boil. And these are what we call changing the states of matter. Substances change the state when they are heated or cooled. So here are the three states of matter once more: gases, liquids, and solids. And I'm going to show you a diagram that shows how they change state, or what they change into, and the names of those changes of state. Right there. So if you think of a solid, it's best to start with a solid. Let's go from a solid to a liquid. Think about ice cream or ice. Solid, what happens when we heat it up? Well, obviously the ice or the ice cream melts, turns into a liquid, so we say that's melting. What would happen if we put that water or the ice cream back in the freezer again, cool it down? Well, it would freeze. So liquid going to solid, we call freezing. Think about the liquid turning to a gas now, so water in a kettle. Water is liquid, the steam that comes out of the kettle is gas, so how do we get there? Well, we evaporate it, but in fact in this case, on the arrow that's going from liquid to gas, I'd also like you to write the word boiling. Because evaporation begins at an earlier stage, we'll cover that in another lesson, but boiling is where liquid turns completely to a gas. Think about a shower. You've got condensation in the shower. That's gas, the steam, hitting a cold surface, cooling down, turning back to liquid again. Sometimes a gas can turn straight to a solid. That's called deposition. Or a solid can turn straight to a gas. That's sublimation. For something to change state, we have to overcome the bonds between the particles. When we heat the substance, we provide kinetic energy, so that particles vibrate more and more until they break the bonds. Melting a solid to a liquid, we need to provide some energy, but the bonds aren't totally broken. Whereas a liquid going to a gas would require a lot more energy, because we have to totally break the bonds. Pause the video at this stage, copy those diagrams down, along with the little yellow writing above the arrows. Right, here's the same diagram as this one. It might not look the same, but it'll have the same information. I'd like you to have a go, pause the video, and have a go at the green tasks, using the words in the box in the bottom right hand corner. And this just talks about the changes of state this time. A, B, and C are the states of matter. I'd like you to just complete this diagram, copy it out, complete it. Look back if you need to at the triangle, 2 slides back, rewind the video if you need to, and have a go at this. So here's the answers. Solids, liquids, and gases, we can tell how they're arranged. Solids, nice, neat arranged pattern. Liquids, irregular, gases all far apart. Freezing, liquid to a solid. Melting, solid to a liquid. Condensation, gas cooling to a liquid. Evaporation or boiling, liquid turning to a gas. Sublimation, solid straight to a gas. And deposition, gas to a solid. If your diagram wasn't correct, please take a moment to correct it. If you get a chance, there's a really good simulation I'd like you to visit if you get a chance. There's a website for it. It's called PhET, and they have a really good thing that you can play around with and see how all this matches and changes. Changing state is a physical change because nothing new is created. When something new is created, it's a chemical change. The mass of the substance also stays the same. What that means is if I have a kilo of ice, it will melt to 1 kilo of liquid, which will boil to 1 kilo of steam. So changing state and mass, take a moment, copy this out, and that's the end of the lesson.